How's it going? You guys hear me okay? All right. Yeah, so I'm Aaron, the CEO of Rocicorp. No one can ever pronounce that. It's awesome. When you make your own company, make sure you pick like a really difficult to pronounce name. I'm super stoked to be here. Thank you all for making it out so early after a late night partying. I came last year and I was super jealous of all the speakers. Really wanted to talk and really delighted to be here to talk to you. I'm visiting from Hawaii. That's where I live, hence these slippers. And as Madison mentioned, I have been a web developer for quite a long time. I feel like when programmers introduce themselves, they should like talk about their first web dev API that they hated, their first browser API they hated. Does anybody know what the layer tag is? Raise your hand. Anybody? I got one clap. Okay. All right. So if you don't know what the layer tag is, look it up after this and count your blessings. Also, this is kind of an interactive presentation. I was going to tell you to tether your phone, but then I tested the tethering, and that didn't work either. So I don't know, do whatever you want, but wish me luck. Okay, this is not. All right, okay. Hopefully this works. All right, okay. So I used React on the very first day it launched. When React launched, I heard about it, I looked at it, I used it, and I fell in love on the very first day. Not to be overly dramatic, but like React changed my life. I had been doing UI development for a long time before then, and I think, when React launched, the React team talked a lot about performance, how much faster it was. But I actually don't think that that's why React won. And I think it is a mistake to understand that React won because it was fast. I think React won because it was incredibly fun. It was a much more fun way to build websites, a much more fun way to build user interfaces. And you can actually think about that mathematically. That's what this diagram is showing. The arrows in the diagram are the crap parts of making user interface. It's the code that changes your UI from one state to another. And before React, you'd have to write code for every transition, from every state in your app to every other state. And after React, you would write only transitions to a common state and then a transition out. So it's actually mathematically true that React is fun. It changes the number of paths in your app from n squared to 2n. But React had a problem also on the very first day, which was that the obvious way to build a React application results in really slow applications, the famous waterfall problem. And so there was this like tension where it's a really delightful way to build software, but if you do it in the obvious way, it leads to really slow applications. And like over the years, we have developed, as a community, dozens of workarounds for this core problem. We have developed loaders, all kinds of different kinds of caching. As soon as you introduce caching, you have to think about invalidation. You have SWR. We have like 17 different kinds of server-side rendering. And when you talk about rendering, then you have to think about hydration and what happens if hydration doesn't match. We've got a zillion different state managers. When you do state, then you start thinking about optimistic mutations. And when you start thinking about optimistic mutations, then you have to think about when this authoritative mutation fails and rolling back the optimistic mutation. And then if you want like full stack reactivity, then you have to think about WebSockets or server-side events. And then what happens if the fetch request isn't consistent with the WebSocket? It's a lot. I don't think these things are bad. Like, I think they have solved the problem. Modern React is a lot faster than classic React. But I think because of that initial mistake of thinking that React was good because it was fast, and not realizing that React was good because it was fun, we've kind of like lost some of the joy that I think brought so many of us to React development. So if the core problem that we're trying to solve with React is the waterfall problem, and that waterfalls make apps slow. Is there some other solution? Is there some other way rather than like patching it with all of these workarounds? And like, the thing that might pop to your mind is like, can we just preload all the data? Like if we could just preload all the data that you need, then you wouldn't have to worry about caching. You wouldn't have to worry about like batching requests together. You would have all the data you need, so you wouldn't have to, the state management would be easier. And this might sound like a crazy idea, but a lot of really cool technology started with a similar kind of thought process. You could think of Git, right? Git just starts with the question, can we just copy the entire directory, every time we want to save? And of course, you can't really copy the entire code directory and save it for every version. But like Linus has said that that's the thought process he started with. And you start there and then you optimize it. OK, we can't copy the entire directory every time, but maybe we can do, we can apply computer science and we can optimize that so that it makes sense. And even React itself, starts with the core idea, can we just re-render the whole page every time anything changes? If we could, that would be a lot easier. That would be a lot more fun. Of course, it's not practical to do that, but we can optimize it. We can apply computer science, and we can make that possible. So that's what a sync engine does. That's the approach of sync. Sync is a different way to architect a web application, different from the classic 3-tier like APIs approach to building a web app. That starts with this fundamental idea, can we just like preload everything, and optimizes it to make that practical. And so if you think about like how do you build a classic web app, today's web app, let's set aside server rendering for a second. Just think about like SPAs. You have your SPA. It talks to your web server using HTTP APIs, and your web server talks to your database. And sync replaces the APIs in that picture. So you have your SPA right here. You have your database here. And instead of an API server in the middle, you link what's called a sync client into your application. It's a library, it's a JavaScript library. You link that into your application. And that talks to a specialized server called a sync engine that runs in the cloud and pushes data to the client. And the basic idea is the app starts up. It fetches all the data it needs, and probably some data that it's going to need in the future. And instead of, whenever anything changes, instead of refetching all of that data, the sync engine is tailing the database. It subscribes to your database's replication log. And so it gets notified, the sync engine gets notified whenever anything changes in the database. It figures out whether that change is necessary for what the client has said that it wants. And then it pushes it down to the client so that the data is already on the client when the client needs it. So instead of having to fetch data whenever you need it and wait for it to come back, you've already got the data, and you can just work with it locally as if it was in memory. And that's how the read path works. And the write path, most sync engines provide some way to, you have the data already on your client, and that enables you to render UI quickly. And most sync engines also provide a way to write to that data locally on the client. And then the write is pushed to your server via like standard REST API in the background. And then your server applies it to the database. So that's a little bit abstract. So to sort of make it real and show you what's possible with a sync-based architecture, I'm going to show you a demo. OK, so this is a bug tracker that we wrote with our sync engine, which is called Zero. And it's called ZBugs. And the reason we made it was because when we started the Zero project, we wanted to make sure that we were building technology that could be used to build real, serious applications. And the best way to do that is to dogfood it and to build a real application. So you can open up this and play with it if you want. But the thing to notice is that every single thing in here responds absolutely instantly. You can do arbitrary filters over the data. You can see they respond completely instantly. We even have like type ahead search. And it's not like a trivial amount of data. As you can see, we've got close to 1,000 bugs in here with all of their comments. And this is the real bug tracker that our project uses for our day-to-day work, and we've been using it for 6 months. So this is live in production. If you file a bug on Zero, this is the tool that you will use. And not only is it fast for reads, it's fast for writes. As you can see, it responds completely instantly. If I add a comment, it's absolutely instant. Next frame, everything changes in the very next frame. And not only that, it's reactive. So if I open this in an incognito window and make a change, so like say I change the status to closed, you see it propagates absolutely instantly. Change it to open. And this happens throughout the application. Hey, somebody commented. Thank you. And this happens throughout the application completely automatically. So here we're looking at open. Hey, you're not sleepy. I'm not sleepy. So we're looking at open bugs right here, right? If I change the status to closed, boom, it disappears. If I change it back to open, it comes back. And I didn't have to do anything as a programmer to cause this to happen. Because my application is built on a sync engine, it just happens automatically. So this is what you get from a sync engine. Instant reads throughout your application, completely automatically, instant writes throughout your application, and ubiquitous full stack reactivity throughout your application, automatically, just from using the API. So it abstracts away all the networking, and you get these benefits for free. So hopefully I've whet your appetite, and you're thinking, hey, maybe I should use a sync engine. I was going to put that cat meme in here. You should use the sync engine. Anyways, get this full screen again. But you might be thinking, like, whenever I learn about a new technology, I'm always like, it's like, it's so hard to get started. You don't know. So what I was thinking in this talk is I'm going to walk you through the basics of using a sync engine. And my goal is to convince you to try sync. I would love you to try Zero, my sync engine, and I think we've done a lot of things right. But there's actually a lot of great sync engines. We're going to talk about 3 today: Zero, Electric, and PowerSync. There's even more than that available, but they all kind of follow a similar pattern. And no matter which sync engine you use, you're going to have a lot of fun. I think you're going to have a lot more fun than you do today with standard approaches. So no matter what sync engine you use, there's kind of like 4 steps. You got to start your sync engine, get it running. You got to configure sync to control what data gets sent to the client. Then you're going to read data to build your application, and you're going to write data. And we're going to walk through each one of these steps. So step 1 is starting the sync engine. And to demonstrate this, I'm going to talk about Electric, which is they have just launched their new cloud service. And it is really, really well done. So all you do is you go to their website. You click on New Source, and you paste in your Postgres connection string here. They only support Postgres. And then you press this button. And I'm not going to do it here because I don't want to tempt fate. But you press this button, and literally 15 seconds later, you have a sync source, and you can start programming against it. It is amazingly well done, very impressive. And full disclosure, we don't have anything like this in Zero yet, but we find this very inspiring, and we're going to do something like this soon, too. PowerSync has a similar setup, although it takes a few more steps. It's more like 10 minutes to get it set up. Yeah, we're going to have a cloud service for Zero soon. So once you do that, you've got this, I'll show you. So once you do that, you get this screen. It gives you a source ID and a secret. And with that, you can start programming. So I'll go into. So when I start with a sync project, usually what I do is I make the world's simplest UI to get started. I mean, you probably do this today with REST APIs. It's the same thing. So I usually make a component that its whole job is just to connect to the sync engine and get data so that I can see that it's connected and it's working. So for Electric, the way this looks is you use an API that they provide in their package called useShape, and you give it the URL of where the sync engine is running. You take that and you pass it into the useShape API along with like the table that you want to sync, the database table that you want to sync, and then you render, and that's it. So like I've got this running here, and there's some data. This is connected to a Supabase table right here. And the cool thing is it's already syncing, right? So this is live. So as you can see, I've got three values, foobar baz. I got 3 values, foobar baz. And if I change something here, change this to monkey, my other like value, there we go. It changes live. So we're already syncing. This is always like a fun moment whenever you're setting up. Change it back. That's that. So that's connecting. Oops. So the next step is you want to configure your sync engine. So what I mean by configuring is like, of course, you can't sync the whole database to the client. That makes no sense. You're going to sync a tiny slice of the database. And you have to configure your sync engine to tell it what slice you want to sync. How this is done in each sync engine is a little bit different. In PowerSync, they have this really cool like cloud-based editor where you log in and you tell it like the tables that you want to sync, and you can do some simple filters on the tables. In Electric, you can extend this params object with like simple filters. In Zero, we don't actually have any step 2. There's no configuration step in Zero, because in Zero you just do queries directly in your client, and whatever queries you request that's the data that gets synced. So it's like completely dynamic based on your queries. This is also where you'll set up read permissions. Each system has a different way to do read permissions. In Electric, they have in PowerSync, they have this thing called sync rules, where you can like similarly use SQL to configure like this data. A user with this user ID should only get access to like rows that have this expression. In Zero, we have a similar system, yeah. So this is configuration. I'm not going to go into a lot of detail here. And then you get to the fun step. Reading data. So when you're using a sync engine, you're pulling data that you're going to need to the client ahead of time. That's the whole idea, you know. And so you end up with like a fair amount of data on the client. You know, like with Zero, it's intended to cache like between 25 and like 100 megabytes of data on the client. With other sync engines, you know, it can be even more. And so it doesn't really make sense to take all this data and just like dump it into an array and work with it that way. Instead, the idea is that each sync engine gives you like a really rich, usually they give you a rich query API that you can use directly on the client to do arbitrary queries over this data. And these queries are reactive. So the actual, not only will, like I showed a second ago, the data changes live, you know, the raw data changes live, but also your query will update live whenever changes get synced to the client. So like, if we look at that, I showed you the dump component for Electric. If we look at the same thing for PowerSync, the way that it works in PowerSync is you do arbitrary SQL queries. And these run against SQLite on the client. And you can do any query that you can express in SQLite, and it will be reactive. And you hook this right up to your UI, and you render from there. It is really fun. Can show you that working. Thanks for the comments, people. OK, so here we've got our 3 data items again. And we're rendering all of them. If I change the query to filter by only the ones that are in column 1, it's actually not going to change because these are all in column 1. But if I change it to, say, like column 2, it goes away. And again, this is fully reactive. So if the data changes backing this, it will live update. And we can do arbitrarily complicated queries in here. So I've done a join to get the column name because the column name is in a different table. And as you can see, it works perfectly fine. You can do any crazy query you want, and it will live update. In Zero, it's similar, but in Zero, the query API is fully typed, like if you've used Drizzle or Prisma or something like that. So you get hints in the UI as you're typing. So you can say like z.query. It gives you the two tables that exist in the database. You can pick whichever one you want. You can do like arbitrary queries, and it's fully typed, so it knows the columns that are available. So I can say I want only the ones that are in column 2, of which there's 1, or I can do all the ones in column 1. And we even have first-class relations, similar to Drizzle or Prisma, but they run client-side and they're fully reactive. So I can do like related column, and now I get a sub-value here. So it's hierarchical. So I get all the items and their column. Or like maybe more useful, like for building a Kanban board, you'd want the column with their items. So do like column, related, tasks. And there we go. We got column with the tasks. And again, fully reactive. If the data changes on the server, this updates automatically. You just take this, plug it right into your UI, and that's how you build applications. So that's reading. Oh God, I'm running out of time. OK, I gotta go faster. Writing. So this is step 4, writing. And every sync engine has a way to do automatic optimistic mutations. They work a little bit differently. In PowerSync, it looks kind of like this. You use SQL again to insert directly into a local SQLite table. And then what happens is, if you remember, if you remember way back here, so it provides an API to do a local optimistic mutation on the client using SQL. And then the sync client library itself sends a request to your server telling it about the change that got made on the client. And then your server runs code to make that change to the database. And then that change syncs back through to the client. So here's how it looks in PowerSync. Then you write like a new API, on a new endpoint that handles the request from the sync engine, inserts the data into the database, and that's how you end up seeing it on a client. In Zero, it's really similar, but we wrap it up like a little bit tighter. We have this concept called custom mutators. And the way this works is you define these mutators, and they work against a class called a transaction that we provide. And this transaction has full access to our query language. And this mutator runs on both the client and the server side. And on the server side, we provide an implementation of the transaction object that runs against Postgres. In the future, we'll provide one for like MySQL, Mongo. And so you can use the same code on both the client and the server. And this can be arbitrary code that uses a full query language to decide how to do the mutation. So this allows you to share the vast majority of the code automatically between the client-side optimistic mutators and the server-side authoritative mutators. OK, sorry, I'm going to go a little fast because I want to get to the end. OK, so that's it. You use those 4 basic steps, and that's how you build your app. And I use these steps to build a Kanban board. and it's in the GitHub repo. I'll show the link at the end. And I built it 3 different ways with 3 different sync engines. And you can look at it and compare them and see the differences between these. And no matter which sync engine you use, you're going to get those core benefits: instant reads, instant writes, and full stack reactivity. But there's one more thing that's really cool. If you think about the way that like classic web apps are built, again, here's like a basic diagram. You got your SPA, API server, database. And you look at the architecture that I showed you with the sync engine. You got SPA, API server, database. It's like almost the same thing. It's like a superset, right? And so what that implies is that you can actually run a sync engine side by side with your classic web app. If you have a web app today that's an SPA that has APIs in it, you can, and then that's backed by Postgres, you can take a sync engine and you can run it side by side with your existing app, and you can just port one feature to the sync engine, or say like one class of users, and leave everything else the same. And because they're both talking to the same database, they'll see each other's changes. So if a user makes a change in the classic app, the sync engine users will see that change live, because it's going to replicate through the sync engine. And vice versa, if the sync engine users make a change, when the classic web app users refresh, they'll have to refresh because they don't have real-time updates. They'll see the change. They'll see the change the sync engines make. So they interoperate, and that makes it really low risk to try a sync engine. But there's even more. Because these sync engines all work on the same basic architecture, you can actually run the sync engine side by side too. So you could have Electric and Zero running, and your classic web app all running against the same database and interoperating with each other. And you could even do it with PowerSync too. You could have 3 different sync engines all running against the same database, and they would all see each other's changes live. So I thought that'd be a fun thing to do. So that's what I built. And you can actually try this right now. Go to this QR code, or syncban.vercel.app. And you can open this, and when you open it, you'll see this little UI picker. You can choose which sync engine you want to use. And you can make changes, and they sync between each other. And yeah, thanks. You guys are helping me out. yeah, and like, it's pretty cool. So I hope this has been interesting. I hope this has whet your appetite. And I hope you'll try Sync Engine and tell me what you built next year.